Hello, and welcome to this episode of Curiosity. This is a series where we will explore how to do data differently through conversations with thought leaders and experts from diverse backgrounds. I'm Simone Knight, and I'll be your host along this journey. I'll be joined by Donald Farmer, who each week will meet with new guests to explore the future of data. The decision making process is growing more and more complicated each day, with humans and machines making decisions together. So, how do we strike a balance? In this episode, we go to the spaces where action happens, and we'll discuss how to take the best of human knowledge and the best of machine capabilities to automate a process, scale faster, and improve the customer experience. Our journey of curiosity begins now.
Hi, and welcome to another episode of Curiosity, our series of interviews and conversations about analytics and the world of data and the world of business and the fascinating and ever more complex interactions between these different important aspects of our life. I'm Donald Farmer, and I'm delighted to be joined today by Mike Bugembe and Ryan Schrupp for what I hope will be just a fascinating conversation. Let's start. I don't really introduce people. I'm much more interested to hear what you have to say about yourself. So Ryan, what's your interest in analytics and the world of business?
So I've been in enterprise research and analytics at US Bank now for about a year, where I'm senior vice president and I'm leading corporate and commercial banking analytics, which is the B2B side at US Bank. But I've been in the business now over 16 years, and I'm excited by data. I'm excited by digging one level lower of the surface. 2, 3 levels lower has always been something that has fascinated me.
That sounds great. And Mike, what about your background? What are you working on just now, and what's sort of interesting to you in the world of data?
So what am I working on just now? It's the same thing, perhaps in a different, if you like, regalia that I've been working on for the last 20 years. I'm passionate about all things data, that whole spectrum of data, all the way through to the world of artificial intelligence and its role in decision making. So I'm really actually very excited about that interplay between human decision making and where the machine comes into play. So that's me.
Well, that's great, because this question of human decision making is going to come up a lot today. Because the topic today is interesting title: analytics is not enough. And when I think of some of the other episodes we're doing, where we're talking about the value of analytics, and now we are saying that analytics is not enough. But I think part of the reason why this is interesting to me is that when I go back through my history of working in analytics, which goes up all the way back to my my teens, really, when I was first starting to work in database technology. We had a different name for this subject area. We called it decision support, which nowadays sounds like one of these ancient terms, but it's actually a great name for what we do. It's a great term. The work that we do supports people in making better decisions. And so decision support software, rather than business intelligence or machine learning or any of these kind of fancy terms, it actually tells you what the software does, which I think is an advantage. Except that nowadays, the scope of decisions has changed dramatically. And as you suggest, Mike, human decision making is a critical element, but we have sort of started to get into a world where automated decisions are becoming more and more apparent and more important in our work. So I wonder, perhaps as you brought up the subject, that sounds to me like you're volunteering to kick us off there. Can you tell us a little bit about the changes that you've seen in the scope of decision making and automation recently?
Yeah, I think if you don't mind, I would love to start on commenting on what you said in terms of what it was called previously, decision support, which I would love to know where that disappeared. At what stage did we stop using that term? Because it is exactly what it does. It does what it says on the tin by you calling it decision support. Because when that term has disappeared, what's really interesting is when people start thinking about what I can do with data or what I can do with analytics, they tend to forget decisions, and they look for more abstract use cases and things like that. Like I often encounter an organization, because I'm a consultant as well. So I work for, I help a lot of organizations in that journey that they've got with data. And the amount of organizations that just have no idea what their key decisions are, and are still trying to apply data and AI and really complex analytics. But for what? They haven't, they've got great decisions here that could really do with the support of analytics, and they're spending all their time on this fancy use case that really adds very little value, right? I digressed a little bit only because I get angst as to why we lost that term the way we described it, because I thought it was really, really helpful. I don't know what your thoughts are on that, but it seems to have caused some problems.
Well, I have a theory about it, which is that it's all down to the marketing people.
Right.
That they want a new term. I've done this. I mean, I've worked in software vendors almost all my career, and the question is always, how do we differentiate ourselves from what everybody else is doing? So if everybody else is saying decision support, you want to say something else, and gradually the term sort of drifts away that way. What I'm waiting for is for the term to come back, the great cycle of life to come round, and we all start talking about management information systems and decision support systems and expert systems again. That would be kind of fun if we got back to that. Ryan, I should ask you then, because this is a really interesting topic, and you were saying that you've been working in this field for quite some time. How do you feel about this shift, from a very decision-focused conversations that we used to have, and now we talk in perhaps more general terms about analytics?
I'm pretty positive about the shift. I remember, and this was not long ago, a couple of years ago, I was working at Target, and our CEO made a pretty, I think, meaningful shift in the way we talked about it. It was this conversation that started with data-driven decisioning, right? Like the data drives the decision. And I don't know, that caused a lot of angst, right? Because there was an element of taking the human out, particularly when we were talking about pricing decisions. And if you take that all the way back to where people's bonuses are paid, that can hurt, right? And we shifted the mentality, particularly as we were injecting more and more analytics into the business, to data-informed decisions, which implied the human plus machine now, but maybe a few years ago, it's just human plus the data, and together making those decisions. So I welcome the change, particularly because it's much easier for me to engage my clients, to get them on board and believe what we're trying to do earlier. So, yeah.
That's interesting, because for me, when you start talking about the difference between data driven and data informed, I start to think of the sort of structures that we talk about: a human in the loop, and I sort of hear three phrases: human in the loop, human out of the loop, human over the loop. The loop being this decision making process, and then the role of the human in it. Mike, I know this is something you've been really interested in and doing a lot of work in. How do you view this this change between data driven, data informed? What are you trying to achieve in your work when it comes to this?
Well, I think I like what Ryan said, where you said, you've made that shift from data driven to data informed. And just to sort of loop it back to what you said, in that sort of includes the human in that whole process, because I think that's absolutely essential. I'll tell you what my fears are. My fears are, with all the excitement around the machine and what data promises, which I love, by the way, that's my field. At the same time, we're getting a little complacent about that and almost doing this whole shift of responsibility onto the machine, or let the machine decide because it's the ultimate authority. And we've now encountered so many situations, even as recently as a few weeks ago in the UK, where we had an algorithm decide what grades the students should have got without the input of some of the teachers, which in fact resulted in some disastrous predictions, if you like, of what those grades should be. And I think that's a really good illustration that whilst we increase our sophistication in the machine and the algorithms that can help us with those decisions, I still think at this stage today, we are still the better big data machine, right? And there are aspects that we are capturing that the machine can't capture. So the machine can only work with the data that it's been given, right? And not everything that we encounter and experience has been coded into a database to enable an algorithm to be trained. And therefore it's missing data, right? It's an incomplete set. And we have more available. And therefore there has to be that fusion of both man and machine, in that we have weaknesses where the machine will be able to play a huge part. So for example, our memory, our ability to calculate and things like that, where the machine is so much more superior. But then our ability to create, to strategize, intuition, and it's almost joining those things up that we really get a massive benefit, and a step change in our ability to make the right decisions.
Yeah, I agree. We're facing such an interesting time in banking right now. And I mentioned earlier, I support corporate and commercial banking, and a lot of that is relationship driven. And we're trying hard to inject more data because we can optimize some of the decisions that are being made. Some are very important. We can optimize credit decisions, and we can do so in a way that doesn't produce errors, right? So that's a very natural place where I'm comfortable not having humans involved, is making sure we're not discriminating, very simply, making sure we're not doing things that don't make sense in terms of like credit risk. But on the other hand, COVID has really opened up the necessity. I'll just put it quite simply, like, how can you train a machine to value the length, the time of a relationship with a client, and what this means when we get out of this? By the pure numbers, we would downgrade clients, we could take credit away from them. But we know, particularly US Bank, who likes to manage to the long term, those types of negative decisions are going to dramatically impact our relationship with these clients. And those relationships we need over the long haul. No machine can tell me that. That's marketing I can't buy. And I have to rely on the relationship managers who are having these one-to-one relationships with these clients, these conversations, to do the right thing in addition to what our data is already telling them. It is not the right thing to do to kick a client who's been with us 20 years while they're down. And they're not going to be out, quite frankly. So we got to be smarter about it, and we've got to be willing to give a little bit too. And like I said just a second ago, a machine's not going to be able to do that.
Donald, do you mind if I jump in here real quick?
Oh, please. Yeah.
Right. It would be interesting because you mentioned something there that was fascinating, where you talked about the reduction of error potentially in the areas, for example, some decisions where you can absolutely trust the machine. What do you do in the case where the historical data itself is skewed, right? Purely because of history. So the machine, you can't blame the machine, the training set, and even your evaluation of what it said based on the training data, it will be pretty accurate. But if the data itself isn't perhaps a skewed representation of what the world looks like, what does organizations like yours do in that case?
Oh, so that's like an everyday problem that we have. I can think of like some pipeline analysis that we were doing, and we were trying to understand, when we pursue a client, we take certain actions, how does that materialize down into revenue that might recognize? And what we see oftentimes is that maybe the client's portfolio is changing. They've sold something. The systems that we use, something as simple as a migration from one type of CRM management system to another, shifts our data entirely. And so I wish I had some like algorithm, some mathematical way to go through it. But this is where, I don't know, maybe it's on the theme of analytics is not enough. You get 3-4 people in a room, and you have to use your best judgment on how you're going to treat the results that come out, or if you're going to narrow your windows, or you're going to shift them. It's so nuanced, and it almost depends too on the domain or the type of analytics that you're dealing with, whether you're dealing with attrition, whether you're dealing with like a share of wallet type of situation, whether or not you're trying to look at prospecting data, like I just spoke about, or client relationship management data, things like that. It's so variable, and it's really challenging, but it's really fun too, because that's what makes it unique. You can't just put it through the machine and crunch it, right? You have to have really deep conversations on it and strategize about how you're going to handle it.
But this change in the data set over time, the fact that the data set you have built over 20 years, in some ways isn't relevant today because 20 years have passed and we're now in a different world. One of the challenges there is how do you handle the inevitable bias which has grown up in the data set? And one of the points I always want to try and get across to my clients is that, algorithms are by their nature biased. There's no such thing as an unbiased algorithm. So, for example, in car insurance, what would an unbiased car insurance algorithm look like? It would give everyone the same policy. It would give everyone the same premium because it's unbiased. But actually, we want it to be biased. We want it to be biased against bad drivers. We want it to be biased in favor of good drivers, and so on. So in a sense, we're not looking for an unbiased algorithm. What we have to do is be smarter, more precise about the biases we want to support and the biases that are unacceptable to us. And that becomes a big problem when you look at historical data sets because they shift over time as well. And our concerns that we had a few years ago may not even be captured in that data set in a way that we can identify them. They may not be dimensionalized in the data set in a way that can be calculated out.
My kids were asking me, how do machines learn? And the easiest way I came up with was you learn from experiences, right? You get put on the naughty step, and so forth. So giving him a reinforcement algorithm, if you like, when you do something incorrect, and you get rewarded when you do. But those experiences as a human being, what's great is they change over time and we adapt to those. The experiences that machine learns from, at least today, is an archaic data set, and we still have this notion, which, makes sense to some degree, that the bigger the data set, the longer it's existed for, therefore the more accurate our algorithm is. When actually that's not the case at all anymore, because the world has moved on so significantly that historical prediction can't work anymore.
I was going to. We're getting to an area. We're getting very close to an area which is kind of fascinating to me, and I think you've both kind of hinted at it. But Mike, it's particularly relevant, I think, to the example you gave of the school examinations. So in the UK, it's Scotland and England, but also internationally, if you take an international baccalaureate examination, which is very much used for international universities, students who are coming up to the end of their kind of school years sit these exams. They're extremely important. They determine, the results of your examinations determine whether you get into university or which university you get into. And this year, people have not been able to sit the exams because of the COVID crisis. And as a result, all these organizations, the education departments in Scotland and England, the International Baccalaureate, have used an algorithm to determine the results of examinations based on history in large part. They've based it on the result of historical examination results and historical teachers' predictions of what the results would be. And they've sort of mashed these up and said, well, based on the history of results and based on the teachers' predictions, we'll give you this score. And it turned out to be disastrous in terms of both public experience of this and in terms of some of the results. And to a certain extent, I feel sorry for the data scientists who perhaps came up with these algorithms, because they're in an impossible situation because there's no sample set to test against. We've never been in this situation before. But it actually raises, to my mind, an even more fundamental question, which is, should this even have been an algorithmic approach in the first place? Was this actually the right way to deal with this? And I wonder if this is actually comes to the crux of the problem. Are there areas where we should not be making algorithmic decisions? And are there areas where we can make algorithmic decisions where they're appropriate? And how do we choose? How do we decide that?
Ryan, have you got a view on that?
I do. I have a bunch of thoughts going through my head. Number one was I hated standardized tests as a kid. I don't think they actually accurately predict one's performance or success, because they're probably, so if I think of having to capture enough data to develop an accurate algorithm that's both usable and has high predictive power, I would hypothesize that you could get 60% of the elements, and then you might be able to sub in other things that could help to replace things that are difficult to measure. Like one of those things that I think is extraordinarily important in measuring someone's success is how much grit they have. And, sports can help with that. Have they been involved with sports at a high level? Typically speaking, folks like that are gritty. So maybe that is. But I've also met enough very gifted and talented athletes to know that that is not the case too. So um, I struggle with the idea of trying to develop an algorithm in education. I think it can give hints, but in the case of what I'm hearing, I don't know a ton about what happened in the UK, but what I'm hearing from you guys, it gives me a lot of angst. I wouldn't have tried it based on what I know.
Well, I guess we don't need to dig into the exam fiasco in detail in itself, but in general, Mike, I mean, are there areas where you would be able to draw lines and say this is an area which is appropriate for algorithmic decision making, and these are areas which are not?
You know what? It's there's some that come to mind, but then as I'm thinking about areas where I'm like, there's a clear distinction here, this is definitely good for an algorithm, I then remember how it's gone drastically wrong, right? Even the self-driving car, at first I was like, oh no, yeah, definitely that seems to work really, really, really well. But then I read an article the other day that said there are certain skin tones that the cameras can't see very well. And so then it's like, well, no, then that doesn't work at all, right? So, so I actually think we're in that really interesting position right now where the way the human mind seems to have been designed has worked really, really well, particularly in areas where we haven't been overwhelmed by an excess of information, right? But we live in a world now where there's an excess of information. And therefore, that has exposed some potential weaknesses in the way, I won't say weaknesses, but operational differences within the human brain. So a lot of biases then kick in because the brain seeks to maintain as many shortcuts in the decision-making process as possible. But when you're overwhelmed with information, it jumps straight to those biases and then is more likely to get things wrong. So I do wonder whether there's a framework, if we build a better understanding of where we have those shortcomings, where the machine can contribute some more. But in order to do that, we also have to understand the machine's constraints, right?
Mm-hmm.
So that we really know whether we can take that for gospel or not, and where that mix is. So I don't think there is a clear cut, Donald, approach for, I'm really trying to think that, yes, 100% this can be an algorithm and this can be human. I do think there's, simply because we're relying on an incomplete data set, right? It's the same as a coin toss. If we knew what the wind was, the weight of the coin, the angle at which it was hit, we would be able to very accurately, more accurately predict exactly where it would land. But there's a whole bunch of extra variables that we just haven't coded yet. So I'm not sure a very clear line.
I think that's fascinating that we never can have it. In a sense, what you're saying is we have too much information, but we can never have enough information.
That's right.
In order to completely model it. Therefore, by its nature, we have to kind of navigate our way through this in an unsatisfactory way, probably.
Yeah. And also, let's think about how we capture data, right? So we capture information typically around the five senses. So what we can see, what we can hear, and I believe now we're coding what we can taste and smell now as well, right? So and there's touch as well, as you can imagine in factories, automobile factories. There's a lot of those sensors there as well. But I gather the scientists have now discovered way more than the five senses, and so therefore those aren't being coded, right? And those aren't being put in databases, and those are definitely used in decision making.
Mm-hmm.
So at this stage, there just isn't enough to rely fully on one or the other.
Right. But when we come back perhaps to Ryan's banking examples, which I think are very interesting. In the old days, if you wanted to get a decision from a bank, you typically met with the bank manager. And it was very much about relationship, wasn't it? I mean, the bank manager assessed you. In my case, as a feckless student, the bank manager, assessed my eligibility for an overdraft, not just based on me, but on the fact that he knew my father and he knew pretty much how well I was doing at university, so what my possibilities were for the future. There was a whole lot of information went into that, but it was very human information. But what was interesting about that scenario is it just doesn't scale. You can't possibly do that 1,000 times a day, while an algorithm can. And the great advantage then of an algorithm is the bank can scale its risk and therefore even out the risk and therefore potentially give more credit and more financial flexibility to more people. So there's a kind of upside and downside to this. Does that make sense to you, Ryan, or am I just trying to
No,
make
it
this too
does.
easy?
I think about, so when I think about the credit risk side of things, it's hugely important. The first thing is we manage risk. The second piece of managing risk, though, and our exposure is actually making sure that we aren't being biased.
Hmm.
And so you said something now, and I don't know if that's what you meant, but we, by having these decisions become automated, we make sure that we aren't excluding groups of people, because that
Right.
happened,
Yeah.
right? And that's illegal, one.
Yeah.
But two, it's as working for US Bank, it's a community bank, we try very hard to make sure that we're having a positive impact. That's a huge deal to me. That's a huge deal to the bank that we're excluding that. Um, and then I think the third thing is like from a customer experience standpoint, no one wants to wait 30 days to get a credit decision, right? So algorithms help us make those inside of days, and that can be very meaningful.
Hmm.
The plumber who was just at my house was beyond thrilled with his bank. I didn't ask who it was at the time because he got a credit decision to buy 2 trucks, which he drastically needed for his business. It was like a life changing thing for him. And he got it inside of 48 hours. And I was just like, that's really good. And so that's a very positive upside case. He was trying to grow his business, but that speed, that sort of thing matters right now. And so I get really excited because of the human impact of some of the things that we're doing with these algorithms.
But isn't the key that you're not intentionally excluding people, but you may be
That's
unintentionally excluding some that
exactly right. And you can pick whatever feature of someone that you wanted to exclude them for, and we're going to make sure that doesn't happen, because the machine doesn't care.
Yeah.
Uh,
So I wonder though, that almost calls for, in order to address the scale issue that you talked about, Donald, and to sort of align to the speed and the gratification that we get around the speed of that. I mean, I've been waiting almost a month now for a new bank account for a charity that I've just set up, and they've got a backlog because of COVID. And I've sat there almost contradictory to what I said and said, why couldn't they just use a machine? It would work quicker,
yeah,
right?
right.
Of course, if they didn't give it to me, then I would have said, why did they use the machine? So, but I do wonder on the if it calls for actually a post that I saw you put on LinkedIn, Donald, around extra policing or some sort of governmental framework or standards to which you can still aim to build the algorithms for, but then within a framework that ensures that you are not, inevitably adding a little bit of bias to what it is you're building. Because we have to remember as well, all of these algorithms are optimized against a particular variable, right? And it's in
right.
case it's risk or it's revenue. And so it doesn't really care who it's excluding or who it isn't, provided it keeps that number within a special set of boundaries that have been,
Yeah, that's true.
I think there's this really interesting area where you can say that there are things which are algorithmically acceptable for sure, because it's a matter of scale, and it's very often a matter of making calculations within a set of parameters. And then there's a kind of human area. There's areas which must be human, and then there's areas where humans can be better informed, or at least can bring a different perspective. The areas which must be human are probably just those high touch areas. I was talking to a doctor recently who said, we were talking about automated diagnosis, and he said, I'd be really, really happy to have a machine learning system diagnose me, but I wouldn't want a computer telling me what the diagnosis was. I'd want that conversation, it's not got no bedside manner. I'd want to talk to a human being about that, which I think is reasonable. But the other approach is, well, the human beings can be there looking at the parameters. We know what the algorithm is that works. That requires a degree of transparency. But there has to be a sort of human element around the parameters of what we're doing. If we have a car, for example, and you have a GPS system which automatically works out the best route, that's great. It's doing calculation that you would find very difficult to do. but you're in charge of the parameters of where you're going, and you're the one who knows, well, I don't like driving over that bridge because it's too narrow, and I don't like going this way because, I'm going to get distracted, and I'm almost certainly going to stop at this store and buy, buy cookies or something. Those are human elements to the decision making, which the machine has no way of doing. So there's parameters that you can bring in. And it seems to me there's always going to be this mix of human and machine. But how do we do that at scale seems to me a significantly difficult problem.
As you were speaking, you mentioned the doctor example, which is one that came into my head actually. And I remember, I don't remember where I heard this from or if I made this up, but I often say when I speak at conferences, try and take the robot out of the human. Because ultimately we consume a lot. Whenever we do any of these, the work that we do, it takes time and it takes energy and we get tired. And when we're tired, our decision-making ability goes down. So in the case of a doctor, where they have repetitive, mundane tasks, where they're asking the same sort of questions, I would almost say that that's robot. Take that out of the human, because the more and more you do those, where you're really needed to optimize true human decision-making, you're not operating from a 10, you're operating from a 2, right? So in that case, for example, GPs tend to have a certain set. Do you call them GPs in the US? I'm so sorry.
Well, yeah, we have family practitioners over here,
okay.
And generalists.
Right. So the general perspective here is that you go in there, they ask you the same set of questions, and then you get prescribed paracetamol, right? All the time. Either decision tree ends up at paracetamol. But those set of prescribed questions that they ask you could be so easily automated, and take that out, so that at least when it gets closer to what the diagnosis could possibly be, then the doctor can really jump in and optimize what they do. So take the mundane out, take all of those repetitive tasks away. I wonder if that's a way that we can create a strong relationship with man and machine in the area of decision making.
Which would be an element of trust there in that. The transparency around trust seems to be an important issue, though. How can we explain what we're doing? To a certain extent, the doctor can explain the diagnosis. You hope they can to the patient. And by the way, I should say, Americans might not understand general practitioner. They also don't understand paracetamol.
Sorry.
Actually, over here it's called acetaminophen, which caused me great confusion for about 3 years at the beginning. It took me a long time to get hold of that. But there's the two nations divided by a single language. But this element of trust seems so... and the relationship between trust and explanation. And I was thinking in Ryan's cases, explaining to somebody why they can get a decision in 48 hours, why it takes a month to get an account, why this decision was yes, why that decision was no. How do you explain that to people in a way that you build up trust with them, even when it's a decision they don't want to hear?
Yeah. One of the initiatives that we were working on the commercial side of the house is we developed some machine learning models to help us understand which one of our customers might need a particular solution to help their business. And these relationship managers are typically used to digging through these portfolios, and over many conversations with a particular client, they will, after assessing their business, our relationship managers are amazing. They get up, they whiteboard with the clients, they're reviewing their business. Maybe it's an account receivables issue, but they act like a doctor. They do. What are your problems? What are you seeing? I want to be able to help you. And so any given relationship manager at US Bank might have 50 clients. And how do you parse through 50 clients? So what we've tried to do is help them figure out how to narrow that list and said, hey, here's your top 10, and here's why. And here's why you should go after them. And then what we try to do is right next to that model this is where we give it that human machine plus aspect, is we give them a knobs and dials type approach in a business intelligence dashboard that lets them start to move the knobs and dials so that they can see kind of what if scenarios and how our model is going to move based on these different factors. And that ability to inject their own knowledge into the situation, maybe it changes the model's results, maybe it doesn't, maybe it just changes the knobs and dials side of these dashboards. But that's critical into helping them see what happens. I've been around this enough. You cannot just go and here's a PowerPoint and trust us because it's the 10th decile And you know what? We used machine learning and random forest, and it just goes right.
This is
That doesn't
great.
work.
Yeah. I mean, I try to make this distinction, which I think you're calling out there, between what I would call an absolute explanation and a relative explanation. An absolute explanation being, here's the algorithm we used, here we used a random forest, here's the input parameters, here's the output. Now go away and learn machine learning and you can come back and you'll understand it. That's not going to help anyone, you know. Well, it may help the machine learning people and it may help auditors and so on who might have to be responsible for that. So there's a place for it. But there's also what I call relative explanation, which is, you know, if we change these inputs, if we change these outputs from that, if we change these parameters, you know, there's still no way you're getting that credit. No matter what we do, that we can't make this work. Or, you know, if we just tweak this thing a little bit this way, then you would get a better score. And I think that helps people to understand not just is it a yes or no decision, but where they fit in the spectrum of possibilities.
Yeah, I agree. And you know, I was just thinking about one of my favorite things to do is when we present a model to our senior leaders, our business partners, we will take out the features that, you know, so top 10 features that have been engineered. And then next to it, we'll provide the impact. And then next to that, we'll provide the rationale, which is really obvious, right? So we'll just use the most generic thing I can think of, which is clients' balances are going down, their deposit balances are declining, and then they shut off. You know, why is that? And we'll give them a list of things that will attribute to that specific item. And in 95% of the cases, it's very logical as to why that specific feature, as it gets higher, attributes to higher rate of attrition. And if you do that with the knobs and dials, people get it. It's very intuitive, and they can kind of forget that the machine just ran how many cycles to basically figure that piece out.
Interesting. Mike, how do you handle this problem of explainability? This must come up all the time in your work. How do you
Oh, it
explain
does,
things?
absolutely. And I think actually you touched on something. Firstly, Ryan, I love that approach of giving the end user a little bit of control. Perhaps, I don't know, I don't want to say illusion, but any bit of control where you have a bit of, you know, influence on the machine's output does seem to inspire a little bit of trust. The challenge we've always had is when explainability is a business requirement, it often means that there is a sacrifice potentially in accuracy, you know, or
Yeah.
you can get from the machine. And so that becomes an interesting balance to try and have to explain, in that, you know, you want the best result, but you also want us to be able to explain how the machine got to that. And in truth, there are areas of machine learning in which we genuinely can't explain, but we know it
Yeah.
works, right? And so it's great to see that you can actually, by giving them a little bit of tweaking, get to that. So it's something I would say I'm looking to now adopt on the back of this call, actually, that there are giving human control can inspire trust. We did a survey one time to try and understand how we can get people to trust machines more, or rather, what is it about the machine means that they don't trust it? And interesting, the highest scoring variable there was that it doesn't get punished, which is really interesting,
Interesting.
that anything that will get penalized for doing the wrong thing, they trust. But if it never gets punished, they don't trust it at all, you know?
That's
That is
fascinating.
fascinating. There has to be consequences.
Yeah, exactly.
I
Yeah. And
love
the
it.
machine doesn't have any. So there's just no
That's
trust there.
insightful. Yeah. You know, when
Yeah.
we come back to your examination, the example of these end of year examinations and the grading of these, the algorithmic grading, and one of the things I suggested was, well, maybe this isn't an algorithmic problem at all. Now, of course, a data scientist looking at this would say, I'm sure we can come up with an algorithm that is fair and accurate. But it strikes me that human sense of fairness isn't algorithmic. We don't do these calculations in our head. We have a different sense of fairness, which is more about, I don't know, justice and equity and things like that are very difficult to parameterize, never mind to model. Yeah. And people just felt it wasn't fair at the time of a crisis, at the time of great emotional stress, to actually apply this in a way which, for one thing, has no consequence for the appliers. I think that's a great insight, but also is just too mechanistic for the emotions that were running at the time. And that seems to me a fascinating kind of distinction between what we accept is algorithmically possible and what we don't accept is algorithmically possible. What we think is it should actually be excluded from those terms.
Yeah, and then there's something as well. I wonder, Donald, if it's that the impact had a really high relationship to being human and what it means in terms of who you are. But the machine's determination here has such a big impact on who you are in your future and what you're going to be, what you've been being raised for, and everything like that. So it's an existential challenge in which if it gets it slightly wrong, has very strong repercussions.
I've had this conversation several times. It's super interesting. And you were talking about at one point the self-driving car and its inability to recognize certain skin tones. And I was talking to some people who are running an artificial intelligence lab in Ethiopia. And one of the things they were saying was it's not a problem of the algorithm not recognizing skin tones. The sensors aren't good enough. The sensors weren't built in countries where there were enough people with these skin tones to be statistically relevant to the conversation. And then they brought in this very human question is, it's not just that you don't recognize our skin tone, you don't recognize us. You're literally not recognizing us as a human being, which is a fundamental question. And I think sometimes we can be kind of technocrats sometimes and think that it's just a matter of tweaking algorithms. And we overlook the fact that it's about our fundamental identity very often. Very human terms. Ryan, you must come across this. I mean, finance is, for better or worse, it's a critical part of our lives. It defines us in many ways. We think of ourselves as, Homo economicus. We live in this kind of world where our economic role in society is critical to us. There's a huge responsibility on you and your teams.
We do come across it. I can't. I'm not coming up with some great examples in it, but the decisions that we end up making can actually be whether or not a business survives, and very realistically, that's happening right now. Or how quickly we can respond, or things like that. That absolutely is something that we have to deal with.
So, as we kind of wrap up this conversation, what do we do about it? I mean, we've talked about a lot of these issues, everything from sort of bias to whether something is appropriate for an algorithm, the performance of algorithms, going beyond analytics. But as we come back into our work and into our daily work, what do we do about this? What can we carry with us in our daily experience that helps us to navigate this complexity?
Well, there's a couple of things that I am very intentional about doing. I again will forgive the machine and forgive the algorithm, but I won't forgive the data set. I won't forgive the coded experiences. So I spend more time on that because it's not, we often look at an algorithm and we measure its success based on accuracy, recall, all of those values that we use to essentially say how well did it do against the training set in optimizing the variable that I wanted to optimize. But we never measure the success of an algorithm on how much does that data represent the way the world looks today. That's not a measure that I've seen many teams consider before they put it through the algorithm. Of course, we have some measures of the data and skewness and things like that we look at to see if there's anything we need to do to correct for certain things. But I think we need to just take some time to spend more time on the data to say, is this a real today's world representation? Number one. Number two, the other thing that I'm really big on is trying to increase the domain expertise. So we, instead of throwing it over the fence to the data scientists, I do think if we want to have a more a human and machine relationship, we need more domain experts who have a better understanding of the world of analytics. And by that also it means we have to demystify that world. We speak in a language that actually makes it really difficult for the average civilian to understand. And I don't know whether we do that for job preservation or what, but there are ways we can really demystify that world in which a domain expert can come in, and literally transform everything overnight. I've been in situations where the moment we added a domain expert and explained what we were doing, he or she just said, "Oh, that's because of this," and
Right.
the
Yeah.
whole thing changed. You know, and there
Because they
was no
understand the mechanism, even if they don't understand
exactly.
the model.
Exactly. And there was no one on the data science team that would have picked that up. We would have gone away and run away with a model that actually would have performed quite well. But until we had that conversation, there were certain changes we would never have thought of making.
Right, absolutely. And so much of that is the language that they use as opposed to the language that we use in technical terms. Gosh, Ryan, can you pick up on that? Or are there things that you would sort of take back into you would advise us to take back into our kind of working lives that can help us to navigate
So
this?
there's one area of definitely overlap with Mike, and I'll touch on that. I think uh, what I'm really focused on right now is applying product thinking concepts and mentalities to the way that we're developing models and the way that we're working with our clients. And so I thought a lot about, or I think a lot about being user focused. So you know, we can develop models that have great statistics, high AUCs, but and we can explain them, but are they usable?
Mm.
So that's one thing that I'm thinking about deeply, because we can spend a whole lot of money producing models, put them out there, and then no one uses them.
Yeah.
And because a lot of our models right now they're not making the decision and then the action. I still need a human to take action. So that's one huge thing that I always have to worry about. One thing that I focus on. The second thing is in what Mike said is we are making a concerted effort day in and day out. The bank is, in addition to our team, on developing domain expertise. To use the word literacy or any of those types of things, we could go that direction for sure, but we are doing that. But the thing that I would add to it that we focus on a lot in my team, and I force it a lot, maybe it comes back to that product thinking mentality, is domain expertise both ways. And so I asked my team pre-COVID, fly out, meet these relationship managers. I want you to be spending days with them. We need to understand their world, what's happening, because it's only going to circle right back when we have to try to develop models that are usable. I have had a number of experiences where data scientists have come into the team on maybe an ad hoc basis or mercenary style, and they don't know my business. They don't know my client's business. And then, the downstream actual client to US Bank, you have to understand those things. And so those are really the two really big things that I'm focused on. The last piece of it is absolutely the data quality side of things. And so that can get really, really, really large. But how do we ensure we're capturing great data? And that's really challenging in my area of the business right now because a lot of the data is self-entered. And so, that directly impacts our models. You can build a pretty Ferrari, you put bad gas in, it's not going to work so well. So those are probably the three big things that we're focusing on. The first two and the product thinking concepts are the ones that I believe are most important right now.
I'd actually like to add one more, if that's okay.
Please, yeah.
And I'm going to take that from Iran as well, and definitely do. I love the idea of if it doesn't get used, if you don't ship product, you've wasted your time. Really, it doesn't count. It genuinely doesn't count, right, until it gets used. But also on the business side, we tend to focus on things that are exciting, the big shiny objects, the ones that everybody else is talking about. And I do generally I think organizations need to think about their business as a system of people making decisions. And when you look at some of those decisions, you will find some low-hanging fruit that will literally just pop out, and they're great data use cases that can be transformational. A quick example is at Just Giving. So Just Giving is an online fundraising platform that was here in the UK. And it allowed people to create fundraising pages to raise money for charity. And one of the decisions you have to make when you're creating a fundraising page is, how much do I want to raise? What sort of target shall I put? And just by applying a little bit of machine learning on that to sort of encourage more people to put targets and also to stretch them just a little bit, this is a 400 million pound a year business that grew 8% just on that decision. And it's little things like that it wasn't even a complex thing to put together. It was maybe a 2-week piece of work. It's a very simple regression equation, just to say, what is this person likely to raise and would increase their chances of coming back and fundraise again. And that was the only 2 questions we were asking. Plop that number in there, and we went from 20% of people putting a target to 98% of people putting a target, and all of them raising more than they would have raised before. And
yeah,
not shiny. It's not a big churn model. It's not one of those things that everybody else talks about. It was just a decision that the user had to make that we could automate and optimize. So I think
that is great. So that really helps us, that I think, to wrap up, because the one thing that comes out of that is how valuable these algorithms can be, how immensely important machine learning can be, and what a huge difference it can make to our working lives, our personal lives. You talk about fundraising. The thing I would kind of want to wrap up with is, we can see how important it is, but at the same time, the conversation we've had also suggests that the human element, both the human element in terms of the decision making and the human element in terms of our understanding of human needs and empathy that have to go into building the models, is absolutely critical. I'd like to thank you both for just a fascinating conversation. We could have gone on for another hour and still be working on this, but I just want to thank you for one of the most interesting conversations I've had. It's just been insightful, practical, and deeply humane, which is the best kind of conversation to have. Thank you very much, guys.
In this episode, we learned that humans and machines have a symbiotic relationship and work best when they work together. I encourage you to identify just 2 basic questions about your business that you can't answer with data, and then work your way back until you can. Don't forget to subscribe to the series. You won't want to miss a single episode. Next time, we'll talk about transforming the culture of data. I'm Simone Knight. Until next time, stay curious.